Kevin. Hi, Gary. I can see you there now. How are you?
Morning. It's raining in Wexford, everybody.
Is it?
The sunny southeast, it's not so sunny.
Oh, well, it's about time you guys got your share of the bad weather, I suppose. Okay, so listen, thank you everybody for joining us. Today this will be more of a general sort of careers presentation about concerning Nikon Precision Europe. A lot of people don't really know who we are and what we do. The name Nikon, or Nikon, Nikon, as you wish. Usually people start thinking of cameras, which is normal. And there are a lot of other divisions to Nikon. That's really what we're here to talk about today. So I should introduce myself. My name is Karl. I am the technical recruiter for Nikon Precision Europe here in Ireland, and I'm joined by Gary Long.
Yeah, my name is Gary Long. I'm a principal applications engineer within the Nikon Precision Europe Ireland team.
Great. So we can give you sort of two perspectives, as it were, about life in Nikon Precision. So I can talk more about the HRist end of things, and Gary can tell you a lot more about the engineering roles and the day-to-day work that we do. So we will mainly be we'll be exclusively talking about Nikon Precision Europe today, who we are, what we do, why we're going to be hiring, the types of roles that we hire for, and then after that, how our training works, what we offer employees, and if you're interested in applying, how to apply with us. So if you do have any questions as we go through this, we will have time to get to them at the end of the presentation, and we should have time. So if you have any questions, hopefully we can address them there. If you would like a longer discussion, I will give you details at the end of this presentation on how to contact us directly, and then we can arrange a time for a later date for a more lengthy discussion about careers with us. So let's start with the history of Nikon, who we are. We were established in 1917. Nikon Corporation. It's one of the world's leading optical companies. So we're most commonly known, as I said, for cameras, but there are actually four divisions of Nikon. We have the imaging division, which are the cameras. We have metrology, which is measuring equipment. And then we also make medical equipment and precision equipment. And precision equipment is the semiconductor arm, and that's us. So our customers would include the likes of Seagate, Texas Instruments, Intel. Any companies that make their own semiconductors would use our tools in the process, manufacturing process. So in 1980, we developed the world's first production-worthy step and repeat photolithography tool. Since then, over 60 models of our semiconductor lithography systems have printed half of all the integrated circuits that have ever been manufactured. So we currently deploy our tools to customers worldwide, with resolutions which will allow us shortly to operate at the 5 nanometer node. At present in Ireland, we work to provide customers with support on our machines that are printing chips at 14 nanometers. So most people don't realize that the chips in the phone or the device that you're viewing this video on at the moment may well have been printed here in Ireland using one of our systems, a Nikon system. And the same goes for most modern technology. Ireland and Nikon Precision are at the heart of it all. So what we do then day to day, maybe Gary, can you introduce a little bit more, or go into a little bit more detail about what we actually do?
Yeah, so the machines that we work on a day-to-day basis are used basically to print lines or expose lines on silicone wafers. And those lines then become the transistors and then microchips. So what we do is we take light from a laser source. So one of our data companies we work with will provide us with a laser. We take that light then and we bring it through our beam system into our machine, and at our machine ends when we start working our magic. We start taking that light, shaping it, and getting it to the right polarization, state, the right uniformity, the size, shape, etc. And then we take that improved light, we bring it through our machine to what we call the reticle mask, which is the customer's stencil of what they want to print. That's essentially their product. We then take that, we diffract it through our reduction lens. You know, Nikon cameras, lenses, we're famous for lenses. It's our strength, so it's the core of our machine. And we then reduce that chip that the customer wants to print down onto our silicone wafer. And we print them over and over again, 365, 24/7. These chips that we print are get printed, as Karl said, at the moment at the 14 nanometer node. We're going to move shortly within Ireland, hopefully to the 5 nanometer node, but we're already at smaller nodes in some of our factories around the world where we have machines. So on a day-to-day basis, we're printing these chips. What's important when you print these chips? Obviously the overlay. So you want to be printing the chips on top of each other, the accuracy. You may need to make sure your machine's in focus, the contrast is good, and you need to make sure that your imaging is good, that you've got everything lined up and working accurately. When we talk about what we do, so there's various different roles, but if you can imagine if you're working inside a clean room environment, so these machines are printing chips at such a small precision scale that defects, particles, hairs, dust, pieces of skin, everything like that can affect the final product, and that will affect and impact our customers' yield. So we have to have an extremely clean environment. So all of our staff that work inside of the clean rooms will be wearing obviously clean room suits, but then the machine itself has a lot of technology built in to ensure that no particles get inside, because no matter how hard you try, it will be generated. So inside our machine is like the silent world. It's free from vibration due to our mass dampers and our anti-vibration systems. It's free from particles because we have obviously the airflow set to not allow any airflow in, all air will flow out, and things like that. The machine itself is quite large. We're the same size as a normal apartment, where it weighs several tons. The lens itself is a few tons. It's about 5 by 2 meters in size, 3 meters high. What else could I say about it? Yeah, so that's pretty much it. I've mentioned a lot of stuff about it.
Very expensive also. They cost what, upwards of $30 million each?
Yeah, upwards of $30 million, depending on the machine. If you go for immersion machines, which obviously we embraced using water between the end of our lens. So at the bottom of our lens, we have water between the lens and the wafer, obviously a very thin layer of water. And that allows us to reduce our resolution even further to achieve those insane sub-nanometer targets for exposure. And then you've got your dry machines that don't use that. So that'll be more about throughput. You want to expose as many wafers as possible, if not at such a critical level, so you can use your immersion systems to print the critical layers, and then use your dry machines. Don't use the immersion water to print the less critical layers. So they can work in unison together to ensure our customers are printing as many wafers per day as possible to meet their goals and make their money, so that they can pay for the expensive machines.
Great. Okay, thank you for that detailed explanation. As you can see, the technology that that Gary has just described is very advanced, and it's so advanced that our customers actually require assistance maintaining it. So we build the tools, we sell it to the customers, but then we provide service ongoing during the life cycle of the tools. That would include installation, wafer production ramp up, or then in sustaining the production environment. So that's really where a lot of our roles outside of Japan are based around. So I just want to explain that, first of all, we are Nikon Precision Europe, which is distinct from Nikon Precision Instruments. If you Google us or look us up on LinkedIn, you may come across Nikon Precision Instruments. That's in corporate, I should say. That's the US. So we're actually based in Germany, and we cover Germany, France, UK, Israel, and Ireland. We are currently looking at the Irish branch, but we are a very international company in that our engineers spend a lot of time, COVID aside, traveling between our different sites around Europe, but also we provide and receive support from Nikon International. So that would include trips to the US or to Japan as and when necessary. Now, the good news is semiconductors are a designated essential industry, and as such, we worked the whole way through the whole COVID lockdown, both of them, and we are still working, although with some changes to our work and training patterns, as you can imagine. So, for example, all the administration and support staff, such as myself, now work from home. Engineers who must be on site, because there are a lot of very hands-on roles, must follow very strict social distancing guidelines. And also then a lot of our training is being conducted remotely at the moment. I will speak more about that later. Intel, as I mentioned earlier, are one of our major customers in Europe. They actually have 3 high volume manufacturing plants globally. One is the US, one is Israel, and one is Ireland. So you can see, as Nikon Precision Europe, we cover 2 of the big 3 for Intel. So while they're not our only customer here in Europe, they are a very important customer of ours, and they do take a lot of our time. Currently, or up until recently, at their site in Kildare, they've had about 40 of our tools on site. Now, as Gary described, these tools are more like a small house, rather than when you picture a tool, it might be something small. They are substantial machines. They have about 40 of those on site, and we had, up until recently, we had about 60 engineers working around the clock at Intel, because Intel do operate 24/7. We had about 60 engineers working there supporting those tools. Now, some of you may be aware that Intel are actually building a new fabrication plant at the manufacturing site in Leixlip. So until recently, they had three separate fabrication plants, fabs they call them, the manufacturing plants. And the new one that they're building at the moment will be the same size again as those three. So it's quite a substantial build. They are investing about $4 billion, I think, into that. And we are one of their key vendors, and we're expecting to be installing a number of our systems in the new manufacturing environment over the coming years. So obviously, it won't all happen in one go. We'll begin with a small number of tools. When they're up running, then we'll be sustaining them, and we'll install the next tool and so forth. So there will be a gradual increase in our headcount over the next couple of years. So we've hired a lot of new engineers this year, and we are planning to hire more engineers next year. And now Intel are planning to open the fab next year. Obviously, everything has been delayed because construction was stopped earlier in the year. And briefly, it has continued now, but there will be some delay. However, our training takes 12 months to complete. So, and I think that's for graduate engineers and experienced engineers. So we have hired, as I said, a lot of engineers this year, and they are now going through the 12-month training program, and we will be hiring more engineers next year. I will tell you more about the training in a minute, but first I'd like to talk about the roles themselves. These are typical roles that we hire for. So at the moment, we're not entirely sure of how many roles we'll be hiring for next year, and I will come back to that as well. But just to give you an introduction to the roles, all of the research, as I said earlier, all the research, design, manufacturing of our tools happens within Japan. And then outside Japan, all of our roles are based around installing and sustaining those tools. So maybe Gary, could you give us a quick introduction to the type of roles that we would have typically on site at Intel?
Yeah, no problem. So as Karl mentioned, all the manufacturing design is done in-house in Japan. We're a Japanese company, and then the machines ship to sites around the world. So in our case, it will be Ireland, or whatever site it would be, Seagate, Analog Devices, Intel. And we have what we call install engineers. So you can imagine a machine ships in modules. The install engineer, then their job is to bring all the modules together and get it up and running. So they'd start off by putting everything together, getting all your air, gas, vacuum hooked up to the machine, start turning things on, start feeling out little problems and working through them, and then eventually get to the point where they can start powering on and setting everything live. Then what they would do is they would start doing rough adjustments, adjusting the machine, get it kind of walking slowly, and then eventually they get it up to speed, running at whatever 700 millimeters per second stage speed, printing 200 wafers an hour. And then comes the acceptance test, where they have to meet obviously our customers' requirements and specs to get signed off and become a production worthy machine. Once the installers are done doing that, another role that we would have would be a field service engineer. So these guys and girls are an exciting bunch of, they're innovative, they're energetic, they work to keep the machines going. They're the heart of the company. I guess they're the guys that are in the fab, working on the machines day to day, making sure everything's running. It's a very important role. It's probably one of the most important roles within the company. And it's a very hands-on role. You're working on the machine, doing things like upgrades, modifications, but most importantly, you're responding to problems, and your root cause analysis and those problems and overcoming them to ensure that the customer has the support they need in the service. So they're service-oriented people, and it ensures our customers to get the most out of our machines 24/7, 365. Karl will explain some of the hours that are involved in that, the shifts and specific things like that a little bit later, I believe. Then you have applications engineers. That's like myself. Our team are there to support our field service engineers, but also very customer facing. So we meet with the customer regularly to address any issues on the machine performance at a higher level. So the machine prints wafers obviously every day, prints a lot of them, but the goal of this industry is to print more, print them smaller, faster, and get as much yield as possible out of each silicon wafer that you expose. So if you're exposing 200 wafers per hour, you want as much yield out of each one as possible. When I say yield, I mean as many working transistors as possible that then could become the microchips. And then other roles we'd have is data support engineers, which would support the applications engineers to be more of a generalist role. So they would have specific knowledge of all topics. So autofocus, overlay, imaging, defects, productivity. And their job would be to support the applications engineer to get quicker turnaround on APs around data analysis and stuff like that. So we're taking big data, taking it in, parsing it, understanding it, and coming up with solutions from that based on the models you already know. But then we have other roles within the company like EICs, engineer in charge. So these people are working on a day-to-day basis to ensure the customer has the plans they need. They have explanations for various errors that might happen. They introduce the QANs or the modifications that the field service engineer would install to create the plans for that. They create best known methods to make life easier for the engineers working on the machine. And then you have things like STL, who would be the site technical lead, obviously leading the site team in all technical aspects. And then you've got site managers, health and safety, all that kind of stuff. That's pretty much all the roles that we have within Intel Ireland and MP that I can think of at the moment.
Okay, thank you, Gary. So just on that, we typically look for a minimum of a level 8 degree in a related engineering field. So for example, electronical engineering, electrical engineering, mechanical engineering, also electromechanical, mechatronics, and so on. We have hired a lot of physics graduates or people with optics backgrounds. For roles such as the applications engineer, we typically require a minimum of a master's level in one or more of those backgrounds. So I just wanted to make a note. Gary touched on it there a minute ago, the shift patterns that we work. So this is something that people should be aware of. Our work does require engineers to work a variety of shift patterns. So it really depends on the customer's requirements. We are in service, and so our customers may require us to work on social hours. The EU Work Time Directive states that the average working time for a 7-day period can't exceed 48 hours, including overtime. But that's calculated over 4 months or more. So we will do 12-hour shifts, 7 a.m. to 7 p.m. for days and 7 p.m. to 7 a.m. for nights. So because of the amount of hours that we do and the EU Work Time Directive, that leads to what they call a compressed work week. So we do 3 days on with 4 days off, or you do 4 days on with 3 days off. And that allows us to stay within the maximum amount of hours allowed. So to facilitate the compressed work week in Intel, they break that into what they call the front end and the back end of the week. So the front end of the week will be Sunday to Tuesday or Wednesday, depending if it's 3 or 4 days. And then the back end of the week will be Wednesday or Thursday to Sunday. So the engineers then switch between days and nights every month, a month of days, a month of nights, and front end and back end of the week every 6 months. And the idea there is that over a 12-month period, all of the engineers have had an equal number of all the different types of shifts. And the good news is we do get what we call a non-social hours allowance. So if when you're working nights or weekends, you will get extra salary. It varies obviously depending on the hours that you work, and that depends on the customer's requirements. So we can't guarantee that you will be working nights. The customer may come to us and say we don't require night coverage, in which case we don't have it. But just as an example, if you were to do 12 months of Intel's shift as just described, it could potentially add an extra 35% on top of your basic salary. So you are well recompensed for the extra hours, and you do get lots of time off if you consider that you're getting 3 or 4 days off a week. We do also have the normal, what we call normal hours. So that would be 8 to 5 Monday to Thursday and 8 to 4 on a Friday. A lot of the roles only work that. So for example, an engineer in charge or an applications engineer, they would be the core hours. However, they may be required at times to work weekends or on social hours, again, depending on the customer's requirements. So we do require a good deal of flexibility from our employees. And then finally, I suppose installations would be a separate matter because, as Gary described, it does take a long time to build one of these tools, and installations can happen internationally. So you could be in France or in Germany installing a tool, and that could take a period of time. So you might be away for a number of months, and and that again depends on the customer's needs. So you might just work a normal 8 to 5 Monday to Friday, or you might do around the clock coverage depending on what the customer needs. Okay, so moving on to training. So as I mentioned earlier, the training does take 12 months to complete, and they are, as Gary has described, very complex tools, and even people who have experience will not have experience on our tools. So they will have to go, everybody goes through more or less the same training. It may break away at the end depending on the differences in roles. The training then is under normal circumstances. COVID has changed this, I'll come back to that. The training is broken into different stages. So initially there will be about 6 weeks of technical training. So that's classroom, theory training, but we would break that up with on-the-job training and mentoring. That would be interspersed with travel to different customer sites. You may be on site here in Kildare at Intel, you may be at Seagate up the north, you might be going to Germany, you might go to the US. It really depends on where we have the capacity. So obviously we can't bring all of our trainees onto the same customer site. So we would break them up, and a small group will go here, a small group will go there. All travel and accommodation and training and anything required around that is paid for by us, fully paid for by us. So what else do we do? We do also have what we call mock-ups. They're basically offline tools, if you will. They are fully functional tools, but they're not in a production environment. As you can imagine, training on a production environment tool is a little bit stressful because you don't want to make a mistake and, you know, cause any loss of time for the customer. So we do have offline tools in different locations globally where we can have a less stressful let's say training. So there would be time on those tools as well. As you can see though, COVID has affected a lot of that. So where and when the engineers undertake the training, it varies. It depends first of all on the availability of the training sites and the tools, but it also depends now on COVID. We will give as much advance notice as possible for travel, but we might require people to travel at short notice. The on-site training initially is Monday to Friday, 9 to 5. Later then it would move to shift hours, depending again on what's available. COVID, as I said, has caused a backlog. So we can't we've hired a lot of people this year. We can't send them abroad for training. And we also can't bring them all onto one customer site because of the social distancing regulations. So what we've been doing is, to keep the process moving, we've been doing a lot of technical training online and front loading basically the 6 weeks rather than breaking it up with hands-on training. It's not ideal, but we have to keep moving. So we have been bringing people on site in smaller groups. We've also been renting very large conference centers, conference rooms where we can bring a small number of trainees in, and at least we're in the same room doing the training rather than all being online. We can get to know each other. So it has slowed things down quite a bit, and that has had a knock-on effect on our recruitment, which is why we're not actually recruiting at this time, but we will restart the recruitment process early next year. I'll come back to that. As soon as the health situation allows, we will be asking our trainees to travel abroad again as usual, and then that will clear the backlog and we can. So then what we offer, and we are, as Gary has mentioned, we are a Japanese company and we have a lot of Japanese cultural characteristics. So for example, in Japan, employees do tend to stay with employers for a very long time. Sometimes for their whole career. It's not unusual. This doesn't happen so much in Ireland or in Europe. As it happens, we do have a very long tenure. We have a lot of engineers who've been with us for 20 years or longer. That's as much to do, I think, with the advanced technology that we produce and the career opportunities that provides for engineers who are interested in that sort of technology, as it is to the excellent compensation and benefits package that we offer. So that's really how the strong employer-employee bond in Japan translates into Europe is really an excellent benefits package. So first of all, we offer a competitive salary. That would depend on the role, the individual's qualifications and experience. So that varies. The benefits package is the same for everybody. So I can tell you a little bit about that. I'm conscious of time. We have a car allowance, which is over €8,000 a year. And that's paid with your salary monthly. So basically you can take your basic salary and add 8,000 to it. And that's for the probationary period. After the probationary period is passed, you can choose to continue receiving that payment, or you can ask for a company car. So we have a number of options there: fully petrol, hybrid, fully electric. We also then get 24 days holidays starting. We get a phone and a laptop. We do get the shift allowance, the unsocial hours allowance that we spoke about earlier, which can add up to quite a lot on top of your basic salary. Although I should stress that not all the roles offer that. It depends on the role. We have an annual bonus which is paid every June. It's calculated according to the company performance and the individual's performance. So the company performance is usually quite strong financially, and the individual performance, you would set goals with your manager, and depending on how well you achieve those goals, that would affect your share of the available bonus. We also get, what else do we get? Oh yeah, sorry, pension payments. The company pays 7% towards the contributory pension. We get top level healthcare insurance with Leia Healthcare that would cover the individual, spouse and children. And then we get things like long-term service awards, because we do have people here a long time, and concessionary products. So if you are into photography, we can get good lenses and whatnot at exceptional prices. So they are the basics, the basic benefits. I just want to stress that our probationary period is a standard 6 months, industry standard 6 months. We have had to extend that recently to 9 months because of COVID. Everybody's training from home. So normally they will be on site with a trainer or on the job training with a mentor, and we're getting feedback on their on how they're advancing. That's not happening at the moment because people are sitting at home alone. So we have temporarily extended our probationary period to 9 months. That will be brought back to 6 months as soon as everybody gets back on site or gets back on a plane to go somewhere for training. And just to wrap it up then, as I said earlier, we have hired a number of engineers this year. It's been a mix of all the roles that Gary spoke about. And what we're doing at the moment, because we can't hire externally because of the backlog in training, is we are encouraging our existing engineers to apply for the remaining available roles. We're very big on career development here in Nikon. It takes us a long time to find good engineers. It takes us a long time to train good engineers, and then we're always upskilling, as new technology comes along, being on the cutting edge of technology as we are. So we would much rather keep engineers. And so we don't want you to feel after 2 or 3 years that you need to go somewhere else for professional development. We will encourage you to stay with us, and we will work with you to offer all the opportunities that we can. So just on that, that's what we're doing at the moment, internal recruitment. When that's finished, all of those roles, the successful people's roles, will have to be backfilled. And then we still have a number of roles from our current recruitment campaign. So that's what we'll be hiring for next year. The bad news is I can't tell you what they are at the moment because I don't know. As soon as this internal recruitment is completed at the end of this year, I'll have a list of what we're hiring for next year, and I will make those available publicly. So the best thing to do would be to follow us on LinkedIn. If you go to LinkedIn and search for Nikon Precision Europe, remember, not Nikon Precision Inc., Nikon Precision Europe, follow us there. As soon as roles become available, they'll be posted there first, and you can contact us directly there. Final thing to say is that if you would like to contact us directly for a longer discussion, you can send an email to, get your pens ready, this is a long one, NPE for Nikon Precision Europe, NPE-Ireland-HR at nikon.com. So that's NPE-Ireland-HR at nikon.com. Send us a copy of your CV. One of our team will be in touch and we can have a longer chat then. So that's about it. Thank you very much for your time. Gary, thank you for joining us.